All right, our next one here, they want us to solve this differential equation. So same thing, we want to separate first. So we want to get all the x stuff to one side, all the y stuff to another side. So if we do that, we times the dx over to this side. On the other side, we'd multiply that denominator over, and we get 2y plus cosine y dy. And then our next step is we want to integrate. So we're going to integrate both sides and see what we get. So on the left side there, antiderivative of 2y would be y squared. Antiderivative of cosine would be sine. And I'm not going to put a plus c on this side because we'll put the constant on the other side. On this one, it would go up to x cubed. We'd want a 2 in front then, so that when we'd find the derivative, we'd get 6x squared. And plus some possible constant. So that would be the differentiable. Now, the last one, we were able to solve this for y, where we got an answer that said y equals something. Not going to be possible on this one because there's no way to separate out these two y's. We can't factor it. There's nothing we can do there. So this one's not solvable for y. Not all these are going to be able to get a y equals type equation when you're done. In fact, not even all these differentiable equations are even going to be separable like this one. There's some that are, there's some that aren't. This happens to be one that's separable, but we're not going to be able to solve it as a function of y. Reason is, if we look at this graph, here's some possible solutions to this differentiable equation. You can see that a lot of these do not pass our vertical line test. And since they don't pass our vertical line test, they're not functions, which means you can't write them in as a y equals type function there. Whereas our last one, this one did, all these ones do pass the vertical line test. That's why we were able to solve that one for y.